Even if you never saw a real piano, I'm sure you are familiar with its keys and the way they are arranged, with the black keys in groups of 2 and 3 keys. Each of these keys, corresponding to a musical note, is named with a letter. Let's start with the white keys. Here are the notes A, B, C, D, E, F, and G. The next white note occupies the same position as the A note, so we call it with the same letter. We say that both A notes are 1 octave apart. The other white keys in the piano are named with the same note according to their position, and the only difference is that they belong to different octaves. What about the black keys? Notice that every black key is in between 2 white keys. Let's focus on this one, that is in between C and D. The corresponding note is said to be an alteration of C or D. If we take C as a reference, this note is called C sharp. If on the contrary we take D as a reference, the note is called D flat. To make it simple, in this video we'll choose the sharps to denote the black keys, and assume that any sharp note has a flat equivalent. And so to know the name of a black key, we just look at the white key on the left, and put a sharp on it. The 12 distinct notes that go between any note, for example C, and the same note in the next octave, are the 12 notes that have been the basis for the whole Western music for centuries, and still are. But notes alone do not make music. The first step to understand how music is built is to learn how individual notes are related to each other. If we take any 2 neighboring notes in the piano, we say they are 1 semitone apart. For example, C and C sharp are 1 semitone apart, as well as E and F, as they are neighboring notes in the piano keyboard. If 2 notes are just 1 semitone apart, we say there is a minor second interval between them. Depending on the number of semitones between 2 notes, the interval between those notes have a different name. For 2 semitones distance, the interval is called major second. For 3 semitones distance, it is a minor third interval. 4 semitones, a major third interval. 7 semitones distance, a perfect fifth interval. And for 12 semitones distance, the interval is called perfect octave. These are just some of the most common intervals, but really any number of semitones between 2 notes will correspond to a particular interval name. And now that we can measure the distance between notes, we can talk about chords. A chord is a set of 3 or more notes that sound harmonically when played together. The distance between notes within the chord will tell us what kind of chord it is. For example, if the 2 first notes of the chord are 4 semitones away, that is, they are separated by a major third interval. And the last note is 3 semitones away from the second note, that is, they are separated by a minor third interval. The result is a major chord. In this case, a C major chord, as the root note is C. If on the contrary we swap the intervals, so we have 3 semitones between the first and the second note, and 4 semitones between the second and the third. The result is a minor chord. So the difference between major and minor chords is merely the interval between their component notes. And this is true regardless of what is the root note. If the root is in the note E, still an E major is formed with a major third interval and a minor third interval. And an E minor is formed with a minor third interval and a major third interval. In 1739, the famous Swiss physicist and mathematician Leonhard Euler studied the relationship between notes according to the interval defined between them, based on the idea that a perfect fifth interval is equivalent to a major third and a minor third combined, as well as to a minor third. and a major third combined. He rearranged the 12 notes of the musical system in an hexagonal grid, so that this equivalence becomes more evident, as we will see in a moment. In the same way, notes are repeated periodically to the right and to the left in the piano keyboard. Also here, the grid of notes can be extended in both dimensions of the plane. This hexagonal grid is called Tonnetz, which in German means grid of notes. For reference, we can highlight the unit cell of this periodic lattice, containing the 12 notes of the musical system. And what does it mean that the grid is periodic? That means that these 12 notes are present in the grid in the exact same relative positions, but shifted in the plane in every direction. Now we can visualize, in a much more intuitive way, the intervals between notes as well as their relationship. A perfect fifth interval defined between two notes 7 semitones away shows up in the Tonnetz as the horizontal distance between two adjacent notes. The magic of the Tonnetz is that this holds true no matter where we start. The interval between notes D and A is a perfect fifth. And so it is the interval between C and G. Major third intervals, present between notes that are 4 semitones away, are represented in the Tonnetz as the diagonals that point down and to the right. And again, the same interval is defined for any two notes along the diagonal across the entire grid. Finally, a minor third interval exists between any two neighboring notes along the diagonal pointing up and to the right. Now we are ready to see how chords can be visualized in the Tonnetz. Let's start, for example, with a C note. A C major chord will then have another note at a major third, in this case E, and the last note at a minor third from E, in this case a G note. Now it becomes evident that the interval between the first and the last note of the chord is a perfect fifth. So a major chord looks like a triangle pointing down in the Tonnetz. But a perfect fifth is also the sum of a minor third and a major third. And those are precisely the intervals that define minor chords. Minor chords are then represented by triangles pointing up. Here, the note on the left corner is the root of the chord, and it is the same for the major and the corresponding minor chord. Notice that major or minor chords are only defined by the interval between their notes. Do you want to know the notes in a D major chord? Just build a triangle pointing down in the Tonnetz, placing the root at the D note. D major chords have the notes D, F sharp and A. Do you want a D minor instead? Then it is D, F, and A. But there are many more types of chords apart from major or minor chords, each with a distinct shape when represented in the Tonnetz. Like major seventh chords, dominant 7, diminished, augmented chords, and many more. Finally, let's see how musical scales are visualized in the Tonnetz. Scales are collections of notes, and they are characterized by how many notes they have, and by their relative positions. For example, the white keys in the piano sound like this, and they form the so-called diatonic scale, one of the most common musical scales, as it is played just with the white keys. The same way chords of the same kind have the same shape in the Tonnetz, any sequence of 7 notes that look like this in the Tonnetz is called a diatonic scale, and you can build diatonic scales starting from the C note, like here, or from any other note of the keyboard. Other kind of scales will have different shapes. Here are some of the most common ones. The pentatonic major scale, the pentatonic minor, or the blues scale. Intervals, chords or scales are just a few basic concepts of music theory that become very intuitive when we learn them with the help of the Tonnetz. but there are more. If you'd like to have a summary of all the concepts we have seen, and more, download the Tonnetz poster or get a printed copy at your home by following the links in the description. Enjoy!